So today we are going to discuss the normal ECG, the normal waves and the normal segments of the ECG. So ECG interprets the electrical activity of the heart. So in ECG, so one thing is very important. In ECG we are only concerned with the depolarization and repolarization of different segments of the heart, and we are only concerned with the electrical activity of the heart. So we know that the heart has two functional units. One is the working myocardium and one is the conducting myocardium. So in ECG we basically measure the electrical activity, the chambers that are depolarized, the chambers that are repolarized, and what is the time that takes for the impulse to spread from one part of the heart to the other part of the heart. So one thing you have to understand that ECG have no direct association with the systole, diastole of the heart, with the valve opening and valve closing of the heart, but indirectly we will interpret everything. But basically the ECG measures the electrical activity, the depolarization and repolarization of the heart, and the spread of impulse from one part of the heart to other part of the heart. So basically the waves, the P, Q, R, S, T, U waves, the segments represents the electrical activity, and indirectly they represents the physical activity. So today we will discuss only the electrical activity, which is the normal waves and segments of the heart, and maybe in future classes we will discuss how it is related to the mechanical activity of the heart. So before going on to the ECG, first we should know the normal conducting system of the heart. So we know the normal conducting system. So we will have a revision of the normal conducting system. So for theoretical purpose, we can say that electrical activity begins in the SA node. So most of you might be knowing that it's a theoretical part. So in normal person we can say that the electrical impulses are produced in the SA node. So for theoretical purpose we can say that the electrical impulses are produced in the SA node and it is transmitted to the AV node. So from SA node to the AV node, the electrical impulses are transmitted via three normal pathway, the anterior, middle and the posterior one. The anterior is called the tract of Backum, the middle one is called the tract of Winkeback, and the posterior one is called the tract of Throttle. So there are three internodal atrial pathway, the anterior, middle and posterior, the tract of Backum, Winkeback and Throttle, and through this tract the impulse reaches the AV node, and following the AV node there is the bundle of His, and the bundle of His divides into right and left bundle branches. You have the right bundle branch and we have the left bundle branch, and so you would be knowing that the right bundle branch is thick and short, whereas the left bundle branch is thin and longer. Then this left bundle branch divides into anterior and posterior fasciculae, then both these bundle branches, right and bundle branches, eventually divides into Purkinje fibers. So SA node, internodal atrial pathway, three of them, AV node, bundle of His, right and left bundle branches, then we have the anterior and posterior fasciculae of the left bundle branch, then the Purkinje fibers. So this is the normal conducting pathway. So there are different diseases that can happen in the conducting pathway, which we will eventually discuss in the future classes. But now today we will only discuss the normal wave. What is the normal wave and normal segments when a normal electrical discharges through a normal conducting system passes through the this myocardium? What's the normal finding? So as we said, first, so these are the waves. We know the waves. The first wave, the P, Q, R, S, T and U. So these are the normal waves and the segments. So first thing, normally in the normal person, the impulse starts in the SA node. The impulse starts in the SA node, and from the SA node, impulse spread through the whole of atrium, and first there is depolarization of the atrium. So this is the first part. So the depolarization of the atrium takes place in two parts. First there is depolarization of the right atrium, then there is depolarization of the left atrium. So the first there is depolarization of right atrium, then there is depolarization of the left atrium. So this depolarization of both the atria, is represented by a small rounded wave, which is the P wave. So the P wave represents the depolarization of right and the left atrium. And so going on to detail of the P wave, the first part of P wave represents the depolarization of the right atrium, and the second half of P wave represents the depolarization of left atrium, the second change. So normally the P wave represents the depolarization of the atrium. The first half of the P wave represents the depolarization of right atrium. Second half represents the depolarization of the left atrium. Then following that, the impulse spread from the SA node to the AV node. We have already discussed there are internodal atrial pathway. So the impulse spread from SA node to the AV node. And the time period taken for the spread of impulse from SA node to the AV node is considered to be the PR interval. So PR interval is nothing but the time taken for the spread of impulse from SA node through the atria into the AV node. So there is two things which I want to say. So there is difference between PR interval and PR segment, which we will discuss in later classes. Broadly, the spread of impulse from SA node to the AV node can be considered as PR interval. So now the impulse have reaches the AV node. Then it goes through the bundle of His. Then it spreads through the right and left bundle branches. Then it depolarizes the interventricular septum, which is the third change. It depolarizes the interventricular septum, and the depolarization takes place from the left to right direction. The depolarization takes place from left to right direction, and this depolarization of the interventricular septum is represented in the ECG by a small negative wave, which is the Q wave. So the depolarization of the septum gives the third wave, which is represented by a small negative wave in the ECG, which is representing the depolarization of the interventricular septum. Then the fourth change, following the depolarization of the ventricles, there is depolarization of the following the depolarization of the interventricular septum, there is depolarization of the right ventricle. That is represented by the fourth wave. Depolarization of the left ventricle is represented by a large positive wave, which is the largest wave because the mass of the left ventricle is the maximum. That's why it gives a large positive wave, and this wave is the R wave. So R wave represents the depolarization of the left ventricle. Then following that, there is depolarization of the right ventricle. There is depolarization of the right ventricle that is represented by a negative wave, which is the S wave. So the fifth part is the depolarization of the right ventricle, which is represented in the ECG by a negative wave, the second negative wave, which is the S wave. Okay. Then there is, so the ventricles are in a state of depolarization. Following that, there is repolarization of the ventricle, the repolarization of whole of the ventricle, and the repolarization of the ventricle is represented by the T wave. So T wave represents the repolarization of ventricle. Okay. Then in some persons, usually it is not present, but in some person there can be a small positive wave after the T wave. So this after the T wave, this is the U wave, and this U wave is produced due to the repolarization of papillary muscles. So we know that in both the ventricles there are small muscular projections called the papillary muscle that have attachment to the caudate tendineae for supporting the cusp of the valve. So eventually there is repolarization of these papillary muscles, and this repolarization is represented by a small positive wave called the U wave. And there are certain intervals. The first important interval is the QT interval. So QT interval extends from the beginning of the Q wave up to the end of R wave, from the beginning of Q wave up to the R wave, and normally it is around 0.42 seconds normally, or it should be less than 0.4 second. And the normal PR interval ranges from 0.12 seconds to 0.2 seconds, and the normal QRS complex ranges from 0.08 seconds to 0.12 seconds. So these are the normal waves and segments of a normal ECG.